Dear students, welcome to today's class. In the yesterday's class, I have explained about set theory, a definition of object, what is the definition of a collection, well-defined collection, set, and different classification of sets, representation of sets. Okay, now we have seen different types of sets also. Now in this class, we are going to see the classification of sets, that means types of sets. How many types of sets are there? What is meant by cardinal number of a set? What is meant by equal and equivalent sets? And what is meant by subset, superset and power set? And that all those things we are going to discuss. Dear students, now we are going to see what is meant by classification of sets and types of set. So in the types of set, so the first is null set or empty set, or another name of this is void set. What is that? The name itself suggesting that what is meant by an empty set means empty means what? Nothing. If a set consisting of no elements, then it is called an empty set. The empty sets are specially denoted with a Greek letter phi. That means a set contains no element is called an empty set. Sir, give me one example. For example, A is a set X such that 1 less than X less than 2 and X belongs to natural number. Tell me, is the set consisting of any elements? No. Why? Because X should lie between 1 and 2 and X is a natural number. Is there any natural number exist between 1 and 2? No, no natural number will exist between 1 and 2. Therefore, set A is a null set. Okay now. So, another example I will tell. So, that is equal to X such that X square is equal to minus 1. X is a real number. Now, is it a empty set or anything? Is there any element whose square is equal to minus 1? No. In the set of real numbers, there is no number whose square is minus 1. But in the set of complex number, it is there. In the set of complex numbers, it is there. But in the set of real numbers, there is no real number whose square is minus 1. So, therefore, this is also an empty set. Understand this. So, again any more set. So, C is a set X such that number of subsets you can say. So, X is such that X square minus 5X plus 6 is equal to 0 such that X belongs to some real numbers. Tell me, is it an empty set? Is it an empty set? No. Why? Because here there are two elements are there. What are the two elements? 2 and 3. 2 and 3 are the elements in this set. Therefore, it is not an empty set. It is not an empty set. Now, I will write one thing here. So, tell me whether it is an empty set or not. For example, there is a set consisting of like this. Is it an empty set? No. Why? Because so it is a set consisting of another set, empty set. Therefore, it is not an empty set. For example, I wrote a set like this. Is it an empty set? Is it an empty set? No, it is not an empty set. Why? Because it is a set consisting of the element null set, empty set. That's why it is not an empty set. So, like that all these are, so this is not an empty set. This is not an empty set. Understand? So, I hope that you understand what is meant by an empty set. Empty set means a set consisting of no elements. Okay. So, let us see the next type. Coming to second type. So, second type is singleton set. Singleton set. The name itself suggesting that singleton. Singleton means what? One element. So, a set consisting of only one element is called singleton set. For example, A is equal to X such that X square is equal to 9 and X belongs to natural number. This is a singleton set. How can you say that singleton set? So, see here. So, what are the elements? X square is equal to 9 means X is equal to plus or minus 3, but X is saying natural number. Therefore, So this is a singleton set. Okay. So like that, a set consisting of S, this is also a singleton set. Okay, right. Another set B is equal to S. It is also a singleton set. That means a set containing one and only one element is called a singleton set. Okay, now, so let us see the next type. Welcome back. So next type is finite and infinite set. Finite and infinite sets. The name itself suggesting finite and infinite. If a set contains finite number of elements, that is countable number of elements, that is called a finite set. For example, A is equal to -1, -2, -3, 0, 1, 2, 3. As it is a finite set. How can you say, sir, it is a finite set? You can count the number of elements 1, 2, 3, 4, 5, 6, 7. Yes. The set contains 7 elements, therefore it is called a finite set. For example, you see the set of natural numbers 1, 2, 3, 4, so on it is. So here, can you count the number of elements present in the set again? No, we cannot say. Therefore, N is a infinite set. Infinite set. Okay, now I will write one set here. Tell me whether it is a finite set or not. For example, B is equal to X such that X square is greater than or equal to 0 and X is a real number. Tell me, it is a finite set or infinite set? Yes, it is an infinite set. Why? So the square of any real number, the square of any real number is either 0 or more than 0. Okay, so this is an infinite set. That means this X contains infinite number of values. That's why this is an infinite set. Okay, now, so here the symbol I am using one symbol. This symbol is called belongs to. This symbol is called belongs to symbol. Understand? So if it is does not belongs to, we write it as X does not belongs to R. This is a does not belongs to symbol. So that means the symbol, this belongs to and does not belongs to symbol should lie between a number, a element and a set. Element and a set. Understand this? So let us see the next type of set. The next concept that we are going to learn is cardinal number of a set. Cardinal number of a set, or we call it as order of a set. Order of a set. Cardinal number of a set. Cardinal number of a set or order of a set. What is meant by cardinal number of a set? Sometimes they are also call it as cardinality. What is meant by cardinality of a set means the number of elements present in a set is called the cardinality of the set. For example, A is equal to -3, -2, 1, 0, 5 is there. The cardinality of this set, that means the number of elements present in set, this is denoted by N of A, otherwise O of A. Sometimes in some textbook like that also they will write N of A. This is equal to how much? 1, 2, 3, 4, 5. So this set consisting of 5 elements. Therefore, the cardinality of the set is 5. Okay, now right. One more set I will write down. So B is equal to X such that X is a letter. X is a letter in the word mathematics. In the word mathematics. Yes, as I already told you, while representing a set, you should be careful about that. Only one letter should be written at only one time. That means here the set B contains the letters M, A, T, H, E. Already M repeated, A repeated, T repeated, I, C, S. Okay, now, so these are all distinct. So 1, 2, 3, 4, 5, 6, 7, 8. So therefore, so N of B is equal to 8. So the cardinality of this set B is 8. But don't say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Don't count like that. So you have to represent only one letter at only one time only. Okay, na? Right. So one more thing. Now what is the cardinality of the null set? What is the cardinality null set is 0. That means this null set contains no elements. That's why the cardinality of that null set is equal to 0. Right. I will write down one set. Tell me the cardinality of that set. What is the cardinality of this set? The number of elements present in that set is. Don't say that, sir, this is a null set, means no. But I am talking about this outside set. That is the set A contains one element. Therefore, the cardinality of the set A is 1. Understand this. Like that, for example, one set is that B is equal to X such that X square is greater than or equal to 0. X belongs to real numbers. What is the cardinality of this set? N of B is infinite. Why? Because there are infinite number of elements are there in the set B. Why? X square greater than or equal to 0 means the square of every real number is always greater than or equal to 0. Therefore, the cardinality of the set is 0. Therefore, from this what can you say? The cardinality of any set is either 0 or it is a whole number. 0, 1, 2, 3, 4, 5 like that. Okay, na? So I hope that you understand this cardinality of a set. So let us go for next concept. Now we are going to see the concept equal and equivalent sets. Equal and equivalent sets. Equivalent sets. Listen carefully. There is a lot of difference between a equal and equivalent sets. First, see here I am writing two sets. A is equal to 1, 2, 3 and B is equal to the set consisting of 3, 2, 1 and C is a set consisting of 1, 3, 2. If you observe, all these three sets contains same elements, that is 1, 1, 1, 2, 2, 2, 3, 3, 3. That is, the order is different. So already we told that in a set, while writing the set, order is not important. Order is not important. You can write down 1, 2, 3 or 3, 2, 1, 1, 2, whatever may be that. This type of sets are called equal sets. These sets of type of sets are called equal sets and they will write it as A is equal to B. That means what is the meaning of this? If you want to say that two sets are equal, first of all, their cardinal number is equal. That means if A contains 3 elements, B also should contain 3 elements and both the sets contain the same number of elements. For example, you see the set here 1, 2, 3. Set B is equal to X, Y, Z. Now what do you observe here? Here only the cardinal number is same, that is n of A is equal to n of B is equal to 3. But what about the elements present in the set? So here 1, 2, 3 is there, here X, Y, Z is there. Therefore, they are not equal set, but they are equivalent sets. They are equivalent sets. Understand this? Okay. So that means to make to say that two sets are equal, their cardinality number should be equal and both contains the same elements. Here only the cardinality of the set, that means number of elements present in the set should be same. Here if A contains 3 elements, B also should contain elements, therefore they are equivalent set. So from this can we say that, from this we can say that all equal sets are equivalent. All equal sets are equivalent. But all equivalent sets need not be equal. Need not be equal. Understand this? So there should be here 1, 2, here simply 1, 1 correspondence is there, that is enough. Okay, na? So I hope that you understand this concept. So let us go for next concept. Now we are going to see a very, very important concept, that is subset, superset and power set. Subset, superset and power set. What is meant by subset? First we will take the concept subset. Yes, I will tell one statement, to say whether it is a right or wrong. Andhra Pradesh is a subset of India. Is it right or wrong? Yes. Why? In India, Andhra Pradesh is there. But in Andhra Pradesh, India is not there. In India, Andhra Pradesh is there. UP is subset of India. Yes, right. Am I right or no? Yes. Hyderabad is subset of Telangana. Telangana, TS. Not TN. TN means Tamil Nadu. TS, Telangana state. S. Hyderabad is subset of Telangana state. So from this, what you can say, if there is a set, big set, any whatever may be the set. If there are small sets are there inside, small sets are there inside, they are called subsets of that set. They are called subsets of that set. Okay. Let us give one example mathematically. For example, A is equal to 1, 2, 3, 4, 5, 6. Okay. Now B is equal to, I am taking 2, 4, 6. Now tell me, all the elements which are in B belongs to A. Right or wrong? Yes. 2 is here, 4 is here, 6 is here. Then we call as B is a subset of A. B is a subset of A. It is denoted by B is subset of A. So this is the symbol of subset. This is the symbol of subset. Always, whenever you are using a set, for the left side is a small set, right side is a big set. Okay. B is the subset of A. Why I am saying A subset? So we will write down number of subsets. Now I will tell the formula how many number of subsets we can write down. Understand this? B is the subset of A. Then what about A? A is the superset of B. That means India is the superset of Andhra Pradesh. India is the superset of Uttar Pradesh. Telangana state is the superset of Hyderabad. Understand that? Reverse. If you talk in a reverse way, the concept superset will come. Understand that? So if you write in a one direction, that is a B is a subset of A, then A is a superset of B. Okay, now understand this? Right. Now we are going to see that how many subsets we can write down. Given a set, how many subsets we can write down. Let us see that. Okay, now let us take one example. For example, A is equal to 1, 2, 3. Now let us try to write all the subsets of A. Right. Let us call it as first subset. S1 is equal to 1. S2 second subset is 2. S2 is the subset of 1, 2, 3. S3 is equal to 3. Understand this? Now what are that? S4 is equal to 1, 2. S5 is equal to 2, 3. S6 is equal to 1, 3. Understand? Next. S6 is equal to 1, 2, 3. Sorry, S7. S7 is equal to 1, 2, that means every set is a subset of itself. That what is the definition of subset? I tell the elements, every element should belongs to the original set. Here 1 belongs to A, 2 belongs to A, 3 belongs to A. Therefore 1, 2, 3 is a subset of 1, 2, 3. And one more thing is that is a null set. That is null set. That means null set is subset of every set. Null set is subset of every set. Then how many we got? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets we got. Understand this? So dear students, now we are going to see the properties of subsets. Properties of subsets. Okay, properties of subset. For example, if A, B, C are any 3 non-empty sets, okay, any 3 non-empty sets. The first one is If A subset are equal to B and B subset are equal to C, then it implies A is subset are equal to B and B is subset are equal to C, then A is subset are equal to C. Okay, na? Right. Second property is, if A is subset or equal to B, just B is subset of C. B is subset of C. Then we say that A is subset of C. Third property, A is subset of B, B is subset or equal to C, then A is subset of C. Fourth one is, A is subset of B and B is subset of C, then A is subset of C. So that means when A is subset or equal to B and B is subset or equal to C, then only A is subset or equal to C. Understand? So remaining all cases, it is strictly subset. That's all. It cannot be equal to. Understand this? Okay. So these are the few properties of subsets. I hope that you enjoyed today's class, and in the tomorrow's class, I will explain about the operations on sets, that is what is a union of sets, intersection of sets, and cross multiplication of sets and difference of sets. All those things I will explain. I hope that you enjoyed today's class. The next class we will see you. So until then, all the best.